This question is about compound X with the empirical formula, so that's the simplest whole number ratio, C2H4O. We've got the infrared spectrum, the carbon-13 NMR and the 1H NMR information in a table. So we've got two figures and a table. If we actually look at the proton NMR at the bottom, we can see that the integration values actually add up to 8, 3 add 3 add 1 add 1. So it's likely that this formula, rather than being C2H4, is C4H8O2, although it could be even bigger than that, but it's not going to be smaller than C4H8O2. If we have a look at the infrared, if we just put a line where the fingerprint region is and just ignore that for now, because our datasheet doesn't provide us information, computer database can do interpretation of the fingerprint region, but not using the datasheet. We can have a look at the datasheet and see what else we've got. So it looks like we've got, and if we go to the datasheet, we can see it looks like we've got this peak, and this peak, and this peak. Okay, so if we go back, we can see those on our spectrum. It looks like we've got this peak is the OH alcohols peak, this is the CH peak, and this is the C double bond O. What else have we got? Then in our carbon, we've got a peak at 210. So if we have a look at the carbon information, a peak at 210, we've got this peak here. So that's C double bond O aldehyde or ketone. We've then got one at around 70. And given that we know we've got an alcohol from the infrared, I'm going to go straight to the CO alcohol ether ester peak. Then we've got one at sort of 30 and one at 20. It's quite hard to say what they are, but we do know that we have a C double bond O, so it's likely that we've got a C next to the C double bond O, and then the bottom one just being the CC type, and then this one is the C that's next to a C double bond O. Here we've got a quartet at 3.9, 3.9 likely to be this, but could be theoretically, we could think it might be 3.7 to 4.1, but that's got two O's and that's an ester. And we know we've got an alcohol for one of our oxygens and an aldehyde and ketone for the other, so it can't be this. What we need to look at is, do we have this, 9 to 10, that would tell us it's an aldehyde, or do we have this, 2.1 to 2.6, which would tell us it's a ketone. And it looks like we've got the ketone. So we've got the C's, the H's on a C that's next to a C double bond O. And also that is area 3, so integration 3. So there's 3 H's in that environment and a singlet because there are no neighbours to the right, no neighbours to the left, no hydrogens either side. We've got this 3.9 we decided was an ROCH, and it's just one. Integration 1, so these two bonds here do not contain hydrogens, they are carbons or something else, but not a H. 3.7 is probably another peak that is COH, so if we have a look, it's could be this again, but how could we have two of those types? We haven't got enough oxygens. What we need to find is where we're putting the OH carbon hydrogen. And the fact that this is area 1 singlet, we know that OH peaks are not split and do not cause splitting. So once we knew we could, from the infrared, that we had an alcohol, we did need to find one of the ones that only had area 1, but that didn't get split because alcohol hydrogens cannot be split. And then we've got 1.2, which is just like the RCH3, area integration 3 hydrogens, but it's a doublet. So what we know is that this R group, I'm just going to rub it out, is actually next to, this CH3 is next to a C with 1H. And we've got a lot of information here. What we need to do now is, this is level of responses, we need to write down what we're deducing from everything to try and score some of our marks. So the first thing we're going to do is we're going to look at that infrared again. So we had an absorption between, this was the one that looked like it kind of came down, looked like this. It was next to this jaggy one, but we had an absorption, this is like a finger shape, between 3,230 and 3,550 centimetres to -1 due to OH in alcohols. We also had an absorption, a characteristic absorption between 1680 and 1750 centimetres -1 due to C double bond O. You could mention the CH, but it's not characteristic because all organic compounds are likely to have that. If we then look at the carbon-13 NMR, which we were given, we had that peak at around 210 parts per million, and that was due to C double bond O. And on the data sheet, it called that aldehyde or ketone, and that kind of confirms what we know from our infrared. We then had a peak at around about, let's go back and have a look, 70 to 80. And when we looked on the data sheet, we decided when we were labelling that was due to a CO in alcohol, ether or ester. We then saw that there was a peak at around about 20 to 30 parts per million, 25-ish. And that was due to, if we go back to the data sheet and we have a look at what we said that was this one, the C's next to a C double bond O, which is still making sense because we know we have a C double bond O. We know we have an alcohol as well. Okay, so this is all seeming to tie together. And then we had a peak at around about 20 parts per million, and that was due to just carbon-carbon chains. Then if we look at our 1H NMR, we saw that we had, again, we had a peak, if we go back, scroll past our data sheet there, 3.9, which we said was this type. And it's a quartet, so that next to it is a CH3. So let me just go back. And we do each of these. So we had a peak at delta 3.9 parts per million with integration 1. So 1 proton living in this environment. And it was a quartet. So 3 adjacent H's using the n+1 rule. So 3 becomes a peak of 4. And remember the type we looked up on the data sheet. So if we go back to our data sheet, this was the 3.1 to 3.9 type. So we're saying it was an ROC integration 1, so 1H in this environment, and next to a 3, so next to a CH3. Then we had our next peak at 3.7 ppm, and we decided that because we couldn't have an ester, that this was going to be our alcohol carbon like that. It was our ROH. It was a singlet integration 1. Then we had our delta 2.1 parts per million that was integration 3 and singlet. Okay, so 2.1 was RC double bond O, C's with H's. The fact that it was 3 meant we're going to put 3. And the fact that it was singlet would be no adjacent H's. And then our last peak was delta 1.2 parts per million. And we said that that was our CH3 type. It was like RCH3. It was integration 3 and it was a doublet. So we're saying it's a CH3 that's joined to a C with 1 hydrogen, 1 adjacent. And remember right back at the beginning I said that because the integration added up to 8, we thought the actual formula, so that was from our proton spectrum as well, our integration equaled 8, so the molecular formula is C4H8O2. So we've got all these jigsaw pieces and we need to pull it together. So we know we've got a CH3 that is next to a C with 1 H that is attached to the alcohol OH. We also know that we've got a CH3 that's next to a C double bond O. So these are kind of two pieces. If we add up the carbons, this adds up to 4. So we're going to combine that to make, remembering that CH3s have to go at the end. CH3, C double bond O. And then we're going to join that to the C with 1 H and a CH3 and an OH.